Welcome back to GlobalWorks TV. From towering forest giants to precision-milled lumber, witness how cutting-edge technology meets century-old craftsmanship in today's modern sawmills. This is timber processing like you've never seen it before. There's something almost magical about watching a massive tree transform from a standing giant in the forest into perfectly milled lumber, ready to build the homes and structures that define our communities. For those of us who remember when logging was done with crosscut saws and pure muscle, today's timber processing operations represent a remarkable journey of innovation and engineering excellence. Let's take you inside a typical American sawmill operation that's embraced cutting-edge technology from Söderhamn Eriksson, a Swedish company that's been perfecting timber processing equipment since 1899. That's right. While the Wright brothers were still dreaming of flight, Söderhamn Eriksson was already revolutionizing how we process timber. Their legacy of precision engineering has made them a cornerstone in modern sawmill operations across North America. NTHE journey begins deep in the forest, where selective harvesting has replaced the clear-cutting practices many of us remember from decades past. Modern harvesting equipment, particularly feller bunchers and harvesters, can precisely select, cut, and delimb trees with surgical accuracy. These machines use sophisticated computer systems to measure each tree, determining its optimal cutting height and ensuring minimal waste. The operator, sitting in a climate-controlled cab, can fell a tree, remove its branches, and cut it to length in less than a minute, work that would have taken a crew of lumberjacks half a day back in the 1970s. Once harvested, these logs are loaded onto specialized timber trucks using hydraulic loaders that can handle loads exceeding 40 tons. The loading process itself is a careful choreography. Logs are arranged by species and size, ensuring stability during transport and efficiency once they arrive at the mill. These trucks, with their distinctive long trailers and multiple axles, are purpose-built for this singular task, representing decades of refinement in forestry logistics. When the logs arrive at the mill yard, they enter a sophisticated ecosystem of processing equipment, and this is where Söderhamn Eriksson's expertise truly shines. The company's integrated systems represent the culmination of over a century of understanding wood processing, combining mechanical precision with modern automation. Their equipment doesn't just cut wood, it optimizes every decision to maximize yield and minimize waste, turning what was once an art form into a precise science. NTHE mill we're looking at today processes primarily softwoods, Douglas fir, southern yellow pine, and spruce, species that have built America's homes for generations. But unlike the sawmills many of us remember, where decisions were made by eye and experience, today's operations rely on laser scanning and computer optimization to determine how each log should be processed. NTHE process begins at the log deck, where an automated sorting system organizes logs by diameter, length, and species. Söderhamn Eriksson's log sorting equipment uses a combination of metal detectors, laser measurement systems, and density sensors to categorize each log. This might seem like overkill, but here's why it matters. A log with a metal shard embedded from an old fence or bullet can destroy a saw blade worth thousands of dollars. Those metal detectors save mills enormous amounts of money and downtime. And from the sorting deck, logs move to the debarking system. Söderhamn Eriksson's rotary debarkers are engineering marvels. The log is gripped at both ends and spun at high speed, while hardened steel arms strip away the bark. The entire process takes about 20 seconds per log, and the bark itself isn't wasted. It's collected and either used as fuel for the mill's boilers or sold as landscaping mulch. This efficient use of every part of the tree reflects a modern understanding of resource management that would have seemed impossible in earlier eras. And after debarking, logs proceed to the log optimization scanner, arguably the most revolutionary piece of equipment in the modern sawmill. This system, which Söderhamn Eriksson has refined over decades, uses 3D laser scanning and X-ray technology to create a complete internal profile of each log. It identifies knots, checks, rot, and other defects, then calculates, in milliseconds, the cutting pattern that will produce the highest value from that specific log. The computer considers current market prices for different lumber grades, the log's geometry, and defect locations to make decisions that maximize return. It's like having the world's most experienced sawyer making every cut, except this one never gets tired and processes the data from thousands of logs per shift. NTHE, heart of the operation, is the primary breakdown system. Söderhamn Eriksson's band mill head rigs are precision instruments that can position a log and make initial cuts with accuracy measured in fractions of a millimeter. The bandsaw blade itself, a continuous loop of steel with carbide tipped teeth, runs at speeds exceeding 100 feet per second. The engineering required to keep such a blade stable and accurate at those speeds involves sophisticated tensioning systems and computer-controlled guides that make constant micro-adjustments. Here's something fascinating. The thickness of a bandsaw blade is typically around 1/10 of an inch, compared to the 1/4 inch or more of older circular saw blades. That difference might not sound like much, but it's called the kerf, the material lost to sawdust with each cut. By minimizing kerf, modern mills recover substantially more lumber from each log. On a large operation processing millions of board feet annually, that difference translates to millions of dollars in recovered product. And after the primary breakdown, cant and board optimizers take over. These Söderhamn Eriksson systems continue the optimization process, scanning each piece of semi-processed lumber and determining optimal secondary cuts. Some boards go to gang saws for further breakdown, others to edgers that trim rough edges to create smooth, straight boards meeting specific dimension requirements. Every machine in this chain communicates with the central control system, ensuring each piece of wood follows its optimal path through the mill. NTHE trimmer systems represent another level of sophistication. As boards exit the primary saws, they're scanned for defects, and computer-controlled saws make precise cuts to remove damaged sections while maximizing the length of clear lumber. These trimmers can make multiple cuts per second, and they're programmed to recognize current market demands. If 8-foot studs are commanding premium prices, the system prioritizes cutting to that length. And Söderhamn Eriksson's integration extends to the sorting and stacking systems. Automated grading scanners evaluate each board, assigning grades based on knot size, grain pattern, and other visual characteristics. Boards are then sorted into bins by dimension and grade, ready for either kiln drying or direct shipment. The entire process, from log entering the mill to sorted lumber exiting, might take less than 5 minutes, a remarkable testament to modern efficiency. What makes this system particularly impressive is its adaptability. Mills can reprogram cutting patterns and sorting priorities based on market conditions, switching from producing studs to producing boards for furniture manufacturing with relatively simple software adjustments. This flexibility would have been unimaginable in traditional sawmills, where changing production meant physically reconfiguring equipment, a process that could take days. NFOR. Those of us who grew up around timber operations, the safety improvements are equally remarkable. Modern Söderhamn Eriksson systems are designed with numerous safety interlocks and automated systems that keep workers away from dangerous cutting zones. The days of workers manually pushing boards through saws or using hooks to position logs are largely gone, replaced by automated conveyors and hydraulic positioning systems. This transformation has made sawmilling, once one of America's most dangerous occupations, substantially safer. NTHE efficiency of these systems also has environmental implications worth considering. By maximizing yield from each log, modern mills reduce the number of trees needed to produce a given amount of lumber. The precision of computer-optimized cutting means more usable lumber and less waste. Even the sawdust and wood chips generated during processing are collected and used, converted into wood pellets for heating, pressed into particle board, or processed into paper pulp. It's a far cry from the burn piles that used to smolder at the edges of old sawmills. This particular mill represents what's possible when traditional American timber industry expertise meets world-class engineering from companies like Söderhamn Eriksson. It's a partnership that honors the craftsmanship of past generations while embracing the precision and efficiency that modern technology enables. Every board that leaves this facility carries with it over a century of accumulated knowledge about working with wood, translated into cutting-edge mechanical and computer systems. Now, let's shift our attention to another fascinating operation, the Toadsmade Sawmill, which has taken a different but equally impressive approach to modern timber processing. What makes this facility particularly interesting is its complete integration of equipment from Mendes Máquinas, a Brazilian company that's become a major force in global sawmill technology. NTHE story of Mendes Máquinas reflects the globalization of the timber industry in ways that mirror broader changes in manufacturing over the past 50 years. Founded in Brazil's timber-rich southern regions, the company built its reputation on understanding the unique challenges of processing tropical and subtropical hardwoods, species that are often denser and more challenging to mill than the softwoods common in North American operations. That expertise in handling difficult woods has translated into equipment that's remarkably versatile and robust. NTHE journey at Toadsmade begins, like our previous example, in carefully managed forests. Modern forestry has evolved dramatically from the practices many of us remember. Today's harvesting operations follow strict sustainability protocols, with selective cutting ensuring forest regeneration and maintaining ecological balance. The harvesters working these forests use GPS-guided systems that map every tree removed, ensuring compliance with environmental regulations and sustainable yield calculations. Once logs arrive at Toadsmade's facility, they encounter what Mendes Máquinas calls a turnkey optimized system, essentially a complete mill in a box. This approach represents a significant shift in how sawmills are designed and implemented. Rather than assembling equipment for multiple manufacturers and hoping everything works together smoothly, Toadsmade purchased an integrated system where every component was designed to communicate and cooperate with every other component. It's like comparing a custom-built car, where each part comes from a different supplier, versus a vehicle designed and manufactured as a complete system from the beginning. NTHE Log Yard at Toadsmade uses Mendes Máquinas automated log handling systems, which employ a combination of overhead cranes and ground-based loaders to organize incoming logs. The system's computer tracks each log from the moment it enters the yard, assigning it a unique identifier and logging its species, dimensions, and quality characteristics. This digital tracking continues throughout the entire processing journey, creating a complete data trail that helps mill managers optimize operations and ensure quality control. One of the distinctive features of Mendes Máquinas equipment is its emphasis on handling a diverse range of wood species and log sizes. While many North American mills focus primarily on consistent softwood species, Toadsmade processes a broader variety of materials, and the Mendes equipment is engineered for this versatility. The log infeed systems can accommodate dramatic variations in log diameter and length, automatically adjusting gripper positions and conveyor speeds to maintain smooth material flow. NTHE debarking system from Mendes Máquinas employs a ring debarker design, different from the rotary systems we discussed earlier. In this configuration, the log moves through a ring of hydraulically controlled cutting arms that press against the bark from all sides simultaneously. This approach is particularly effective for irregular logs or those with significant taper, as the arms independently adjust to maintain optimal pressure. The result is clean debarking without excessive removal of the valuable wood beneath the bark, a consideration that becomes increasingly important as log costs rise. And after debarking, Toadsmade's logs pass through Mendes Máquinas' proprietary scanning and optimization system. Like the Söderhamn Eriksson equipment, this system uses laser profiling to map each log's geometry and defects. However, Mendes has incorporated some unique features based on their Brazilian heritage. Their software includes algorithms specifically designed to handle the internal defect patterns common in certain hardwood species, calculations that help mills process challenging materials more effectively. NTHE primary breakdown equipment represents Mendes Máquinas' core competency. Their band mill head rigs feature some particularly clever engineering. The blade tensioning system uses both mechanical and hydraulic components to maintain optimal blade stress across varying temperatures and cutting loads. Anyone who's worked with bandsaws knows that blade tension is critical. Too loose and the blade wanders, too tight and it breaks. Mendes' system continuously monitors blade temperature, cutting load, and vibration, making real-time adjustments to maintain ideal cutting conditions. Here's an interesting technical detail. Mendes Máquinas designed their main saw carriages with what they call anti-vibration geometry. The massive steel frames that hold and position logs during cutting aren't just strong, they're specifically shaped to dampen vibrations that could affect cut quality. This attention to mechanical dynamics reflects decades of experience in building equipment that maintains precision under the tremendous forces involved in sawing large logs. NTHE cant processing equipment continues the theme of integrated optimization. After initial breakdown, cants, those square-edged pieces of semi-processed lumber, move to multi-blade gang saws. Mendes gang saws can run up to 8 blades simultaneously, slicing a cant into multiple boards in a single pass. The spacing between blades is computer-controlled and can be adjusted automatically based on the cutting bill, the production plan for that particular cant. This automated adjustment saves enormous amounts of time compared to manual blade spacing changes, which could take hours on older equipment. Edge trimming at Toadsmade uses Mendes Máquinas twin arbor edger system. These machines have 2 saw arbors positioned parallel to each other, allowing them to trim both edges of a board simultaneously. The positioning is controlled by optical scanners that detect the board's edges and any defects, calculating optimal trim positions in real time. The saws themselves use what's called scoring technology. Each main blade is preceded by a smaller scoring blade that makes a shallow cut, reducing tear out and producing cleaner edges. It's a technique borrowed from high-end cabinet making, now applied at industrial scale. NTHE crosscut optimization system is where Mendes software really demonstrates its sophistication. As boards travel down the trimmer line, high-resolution cameras capture images of both faces. The software analyzes these images, identifying knots, splits, stain, and other defects, then calculates cutting patterns that maximize value recovery. The system maintains a database of current lumber prices across dozens of different grades and sizes, ensuring decisions reflect real-time market conditions. For a mill manager, it's like having an expert grader making perfect decisions on thousands of boards per hour, impossible with human workers, yet critical for profitability. One particularly innovative feature of the Mendes system at Toadsmade is what they call the board tracking system. Each board receives a virtual identity as it passes through primary breakdown. As it moves through subsequent processing stages, the system maintains a complete history: which log it came from, what cuts were made, what grade it received, where it's stored. This level of tracking helps with quality control and inventory management, but it also provides valuable data for optimizing the entire mill operation over time. NTHE sorting and stacking systems complete Mendes Máquinas' integrated approach. Lumber is automatically sorted into bins based on species, grade, and dimension, then moved to automated stacking systems that build packages ready for kiln drying or shipping. The stackers can build packages with precise spacing between boards, critical for air circulation during drying, and they work continuously without the fatigue that affects human workers during long shifts. What's particularly impressive about Toadsmade's adoption of this complete Mendes Máquinas system is the unified control interface. Mill operators work from a central control room where they can monitor and adjust every aspect of the operation. Real-time displays show production rates, equipment status, and efficiency metrics. If a problem develops, a blade needs changing, a sensor detects a jam, the system alerts operators immediately and often suggests solutions based on its diagnostic programming. This turnkey approach also simplifies maintenance and support. When every piece of equipment comes from a single manufacturer, spare parts inventories are more manageable, and technicians develop deep expertise with the specific systems they're maintaining. It's a philosophy that makes particular sense for mills in remote locations, or those without extensive in-house engineering resources. NTHE Toadsmade operation showcases how modern sawmilling has become as much about information technology as mechanical engineering. The physical equipment, impressive as it is, would be far less effective without the sophisticated software managing material flow, optimizing cuts, and coordinating activities across dozens of interconnected systems. Our final stop takes us to LABE WOOD, a European operation that offers yet another perspective on modern timber processing. This company has carved out a specialty in handling round timber, logs processed with minimal intervention to preserve their natural character while preparing them for specific applications. LABE WOOD operates in a fascinating niche of the timber industry. While the mills we've examined so far focus on breaking logs down into dimensional lumber, LABE WOOD processes logs that will be used in applications where their round form is preserved: construction timber for log homes, landscape architecture, marine pilings, and utility poles. This specialty requires different equipment and techniques compared to conventional sawmilling. NTHE company processes primarily European softwoods, spruce, pine, and larch, species known for their straight grain and natural durability. The logs arriving at their facility undergo quality assessment focused on different criteria than standard saw logs. LABE WOOD's graders look for straightness, minimal taper, and absence of spiral grain, characteristics critical when logs will be used structurally in their round form, and their debarking system is gentler than what we've seen in dimensional lumber mills. LABE WOOD uses ring debarkers with carefully calibrated pressure to remove bark while minimizing damage to the wood surface beneath. This attention to surface quality matters because their finished products will often be visible in their final applications. Nobody wants pressure marks or gouges on the log walls of their mountain cabin. After debarking, logs pass through a sophisticated grading and measurement system that evaluates straightness, taper, and diameter consistency. Laser profiling creates a three-dimensional map of each log, measuring diameter at multiple points along its length. This data determines the log's suitability for different end uses. Perfectly straight, consistent diameter logs command premium prices for log home construction, while logs with more taper might be directed toward landscape timbers or other applications where precise geometry is less critical. LABE WOOD's processing includes what's called stress relief cutting, shallow longitudinal cuts that help prevent checking and splitting as logs dry. These cuts are carefully positioned based on the log's growth ring orientation, allowing internal stresses to release in controlled ways rather than creating random cracks. It's a technique that combines traditional understanding of wood behavior with modern precision machining. NTHE facility also operates sophisticated drying systems designed specifically for round timber. Unlike dimensional lumber, which can be kiln-dried relatively quickly, large round logs require slower, more controlled drying to prevent surface checking and internal cracking. LABE WOOD uses both air drying yards and climate-controlled storage areas where temperature and humidity are carefully managed throughout the drying process. What makes LABE WOOD's operation particularly interesting is how it represents the diversity within modern timber processing. Not every log needs to be cut into 2x4s. There remain applications where wood's natural form is valued, and companies like LABE WOOD have developed specialized expertise in serving those niche markets. Their success demonstrates that even in an era of mass production and standardization, there's room for specialized processors who understand specific market needs and have invested in the particular equipment and knowledge required to serve them effectively. It's a reminder that the timber industry, despite all its modernization, still values craftsmanship and specialization, qualities that have always defined quality woodworking.